Hello, everyone, and welcome to today's 802 Tech Talk on IEEE 802.15 Wireless Specialty Networks. My name is Jennifer McLean. I'm Senior Manager for Education Products with IEEE Educational Activities, and I'll be helping to moderate today's event. IEEE is the world's largest technical professional organization dedicated to advancing technology for the benefit of humanity. Please note a few housekeeping items before we get started. At the bottom of your screen are engagement tools that are resizable and movable, so you can move them around to make the most out of your dashboard space. If you have questions for today's panelists, you can submit them through the Q&A widget on your screen, and we'll answer as many questions as time allows. If you click on the green resources icon at the bottom of your screen, you'll find more information about IEEE 802 standards and past and future virtual events. And finally, the on-demand link for today's Tech Talk will be emailed to all registrants approximately 2 hours after we finish. And if you'd like to tweet about today's event, please use the hashtag IEEELearn. James Guild has 28 years experience in a variety of areas, including radar absorbing materials, RFIC, RF system specification and architecture development, and MAC protocols. He's been a contributor to international communication standards for 21 years, primarily in IEEE 802. He's held a variety of leadership positions in 802 and is currently the IEEE 802 LMSC Executive Committee First Vice Chair and the IEEE 802.15 Working Group Technical Editor. He joined General Atomics Aeronautical Systems in 2016 as the Principal RF Systems Engineer. Benjamin Rolfe chairs the 802.15.4 AB Task Group and the 802.15 Working Group and is the Vice Chair of the 802.24 Technical Advisory Group and is the Treasurer for the 802.15 Working Group. He has been a significant contributor and member of the technical leadership of 802.15 for more than 15 years. And he currently is the Principal Technologist for Blind Creek Associates and the Chief Technology Officer for the Ultra Wideband Alliance. We welcome everybody today, and I'll turn it over now to James to get us started.
All right, thank you, Jen. Before we get started, I want to emphasize that these are the views of the panelists, not the IEEE. And I also want to remind the audience we will open the floor to questions when we finish the slide deck. Please put your questions in the question and answer box as you're presenting, and we'll do our best to answer them live at the conclusion of the presentation or offline as necessary. So IEEE 802 LMSC interoperability standards play a crucial role in the global economy. They enable inventors and companies to move technologies from research labs into products and services commercially available worldwide. So let's get started with a brief overview of 802's organizational structure. Broadly speaking, 802 is organized into working groups that develop interoperability standards tailored for specific wired and wireless networking markets and the means to interconnect them. For over 40 years, IEEE 802's mission has been to develop high-quality, market-driven interoperability networking standards. Today, Ben and I will explore IEEE 802.15 wireless specialty networks. Hey, Ben, thanks for taking time to share your thoughts on the important activities for IEEE 802.15 WSN, particularly in the areas of ultra-wideband, or UWB, body area networks, or BANs, light communication, and terahertz. So the first question for most people, good morning. The first question for most people is, what the heck is a wireless specialty network?
Yeah, James, that's a good question. Yeah, that's the next good question, and I get that a lot. The answer I usually give is it's wireless everything else. So everything that isn't wireless LAN in 802 seems to fall into 802.15 these days. And it's developed as a family of diverse standards with a lot of varied capabilities and applications. And when I say varied, I mean really varied. So we have standards that support data rates of less than 2 kilobits per second up to over 100 gigabits per second. And we're even talking with the terahertz stuff in 15.3 now at, terabits per second. And we have applications where the communication range needs to be nearly contact in the millimeter wave area, for example, to many, many kilometers in some of the standards. And then, of course, almost every frequency imaginable, we've got sub-gigahertz RF, we've got mid-band RF, we've got millimeter wave, and with the terahertz stuff, we've also moved into light communications. So while we don't go all the way down to DC, we do go past daylight. And so that gives you an idea of the sort of diverse range of things that have fallen into it. And the key is that we have a family of standards each, which is focused on, again, a fairly broad range of applications, but optimized for certain things. So we have multimedia, which is the focus of 15.3. We've got things like medical body area networking, or what I call very personal area networking, which is the focus of 15.6, which is also now expanding into the human-to-vehicle interactions. 15.4 covers such a wide range of things, from very, very low power wide area networks to all manner of Internet of Things. In particular, a lot of adoption of sub-gigahertz 15.4 into smart energy, smart cities, and things like that. Wireless sensor networks. And then with the more recently, ultra-wideband is finding its way into mobile devices, high volume consumer devices, including your mobile phone. If you've got a recent one, you've got 15.4 ultra-wideband in there, and you probably don't even know about it. And this is enabling very precise location and navigation applications. We've also kind of become the home for some of the other standards that were developed in separate working groups and then merged in, like the metropolitan area networking defined in 15.6 and the and 802.15. So yeah, it's
that's a pretty big family of standards, Ben. Let's talk about how the work in 15 is organized.
Okay, James. So this chart shows all of the groups. We've got the green ones show you the groups where there's currently work in progress related to the different standards. As you can see, we've got 15.3, 15.4, 15.6, 15.7, 15.8, 9, 10, 13. And then the 16 and 22 are the standards that were moved in from other working groups. The active ones right now, we've got a lot of activity in optical communications. We've got activity in the multimedia standard 15.3, bringing in some additional features and rolling in the terahertz stuff and the proximity communication stuff. And then, of course, in 15.4, we've got several active task groups that are working on new features to the standard. And one of the key areas of focus is ultra wideband. That's happening in TG4AB. And then we're currently, as I mentioned, 15.6 is looking at expanding the body area network concept to the human body to vehicle interfaces. And then there's a lot of activity in optical we've got going on now.
Excellent. So what are the applications for these networks that you're developing standards for?
Well, there's a lot. And as I mentioned, and you see different standards focusing on different things. So the optical communication, we've got 15.7 and 15.13, which are different approaches to optical. We've got 15.3, which is focused on multimedia, which, as I mentioned, we've got millimeter wave and terahertz are both seeing active use. What I call wider area networking, everything from field area networks to metropolitan area networks to the regional area networking, we've got 15, 16, and that's actually 802.22. Sorry, there's a typo there on the slide. And then also in 15.4, we've got the very low power, very long range capability. And then when we look at 15.4, it's kind of the most prolific standard that you weren't aware of. It's in all kinds of things now. Low power sensors, localization applications for locating and tracking things, assets, people. We're seeing it in automotive for things like secure entry and your smart key being replaced by your smartphone. Industrial networking, critical infrastructure monitoring, and it's finding its way into consumer devices with rapid growth in that area. So a lot of different applications with a lot of distinct personalities.
Excellent. All right, so let's see if we can sum this up a little bit here. So she said this is sort of the most popular wireless standard you don't notice. As you said, it's in your phone, you don't even know it's there. What else can you tell us about it?
Yeah, it's in a lot of other devices that are like that. You find wireless game controllers, a lot of sensor networks in both industrial and consumer markets. So the things that that are monitoring the environment, or even in some cases like the sensors you put on your doors and windows that are connected to your smart home system that tell you if the door or window is open or not. Things like that. It's 15.4 is widely used especially the sub-gigahertz bands, widely used in smart utility, smart city, and low data rate IoT. And we've even seen 15.4 applied to things like positive train control. And of course, in 15.6 is prevalent in medical devices, even sometimes devices that go inside the body, which we might describe as overly personal area networking. And then, of course, the last few years has seen a huge explosion in the ultra-wideband adoption for very precise location services. And one of the interesting applications in the last 2 years has been contact tracing. So being able to keep track of who you've come in contact with and being able to measure that proximity very accurately. And of course, it's, as I mentioned, been used in the secure entry application for vehicles and buildings, where your personal device becomes the key. And the multimedia that I mentioned, another one that you probably haven't thought about, but 15.3E is used in the things like at the Tokyo Olympics, when you got on the train, as you tapped your phone on the kiosk to pay, to get on the train, it downloaded 2 hours of high def content in that quarter of a second you were passing by the kiosk, as you were on your way to the event, based on the your event ticket that was on your phone, and that's based on 15 standard. So,
all right, excellent. So we got a few questions in the chat box here. Here's one that says, "What is ultra wideband, and why is it becoming more important now?" I think you've done a lot of work in ultra wideband, so I think you're pretty qualified to answer this.
That's a great question. So ultra-wideband refers to a very wide bandwidth signal, but is usually, in the context of what we've been talking about today, James, is generally impulse radio. And so that differs quite a lot from conventional carrier-based or continuous signals or digital baseband signals like OFDM, which again are a continuous transmission that's then modulated, or data is modulated onto. An impulse radio is exactly that. It's a series of very, very short pulses. And thanks to the laws of physics, or as one of my physics professors referred to them, not so much laws as gentlemen's understandings, there's a relationship between the duration of a pulse and the bandwidth occupied. The wider the bandwidth, the shorter the pulse, and vice versa. And so a very short pulse with a very steep rise time can allow estimation of the arrival of the signal very, very accurately, down to sub-nanosecond level. And the speed of light travels at a fairly predictable rate. We consider it a constant for practical purposes, about a nanosecond a foot. So you can do the arithmetic and say that, if we can get down to a fraction of a nanosecond, we can get down to a fraction of a foot. And that is what's excited a lot of applications. So there's other applications for ultra wideband that are very, very interesting, because another characteristic of impulse radio is that it tends, if you've got multiple transmitters in the same area, they tend not to line up, which means they don't interfere with each other. And you can have a lot of devices in a small space. And that's also igniting a lot of interesting applications like streaming audio for gaming and things like that.
All right. I'm going to remind everyone in the audience to submit any questions you have in the Q&A section. Here's a question. What is the difference between a band, a body area network, and a PAN? They're both kind of small networks, right?
Yeah, well, but really, Anna, but really, one of the reasons we changed the name of the working group from personal area networking to wireless specialty network is because the application of our standards has gone well beyond the personal area. 15.3 is still very focused on that, so that would tend to be devices that are within either very close to the body or the user, or not necessarily even a person in the, but the two devices. And they might be from, a centimeter to tens of meters apart. And in the body area network, we're generally talking about things that are either on the body, in the body, or very close to the body, and typically do not scale to very large networks. And so the key difference really is in the architecture and the topologies for the network supported.
Okay. So I have another question that says, what would you say are the top 3 challenges to developing standards?
The top challenge is probably consensus building. Good standards come out of good ideas, and good ideas come from smart people, and you get a bunch of smart people with a lot of good ideas together, and there's often conflicts and lots of different ways to do things and solve the same problem. And maybe the biggest challenge in the standards development is building that consensus, and that might be tied with the really identifying what is the relevant work that we need to do in the standards. That's a big challenge, and that's one of the areas where I think 802 overall and 802 leadership has worked very hard to try to give us a process by which we can identify when something is relevant and important work to take up.
Okay, that sounds good. So why terahertz, and what are the challenges of terahertz, and why are we even going that high in frequency?
Well, so the reason is lots of bandwidth. A few years ago, when regulators started to allocate unlicensed bands up in the terahertz range, they were the biggest chunks of spectrum we'd ever seen given away for free. And so with lots and lots of spectrum comes the ability to do very, very high data rate systems. And so that's the appeal, is lots of spectrum that allows you to move lots of bits per second. The only thing, the only thing you have to do is figure out how to make it work.
I mean, specifically, what kind of technical challenges or terahertz are they facing? Can you think of?
Yeah, much as when the millimeter wave bands were first allocated, nobody really knew how to make it work. How do you get a signal? How do you generate a signal at that frequency? And how do you overcome the natural impairments that exist in atmosphere and environment at those frequencies? So there's a lot of technical challenges, and like a lot of things, again, when the spectrum was first allocated, no one really knew how to make terahertz communications work, how to generate a signal, and today we have practical systems that are being demonstrated and starting to approach commercial deployment. So it's one of those, if you build it, they will come. You provide a resource and an opportunity, and people will innovate.
Okay, excellent. So I have another question. It says the 802.15 working group appears to be a good incubator for wireless technology standardization. Has there been any discussion in the group to spin off the standardized technologies that are post-incubator phase of a technology's life cycle? Now, I assume that means maybe to make a new working group out of it or something.
I'm not aware of discussions to split up the working group. In fact, we've kind of been going the other way, merging working groups into it in the last few years. But there is there is a bit of effort going in right now to looking at ways to better organize the working group and the standards within, that the working group maintains and creates. This is an ongoing process because, again, the goal is to remain relevant and address the needs of the industry, including those needs that we may not have anticipated, until they become the opportunities present themselves. So, but yeah, I don't know if there's been any talk of splitting it up, but there certainly is always work going on to make it work smoothly and more efficiently.
Okay. So I have another question here. It says, what level of expertise is needed by individuals who develop the standards?
Well, that's another great question, and it really does take all kinds of people. And one of the fun things that has kept me engaged in 802 for so long is that you get to meet a lot of really smart people with very different backgrounds, very different skills and expertises, and it's when you combine all of that. So really the only thing you really have to have is the willingness to show up and contribute.
Okay, thank you. One last question, and then we'll probably wrap up here, I think. It's what's next for 802.15 in this upcoming year and into 2023?
Well, the immediate future, which is, I think, is very exciting. We're seeing the ongoing work in advancing ultra-wideband in 15.4 AV. We're seeing some efforts to clean up and reorganize 15.3, which would support further adoption of millimeter wave, as well as start to promote the rollout of terahertz stuff. We're seeing more focus on things like the human vehicle interaction and the communication required for that in 6. These are the key ongoing, and then obviously optical. I almost forgot. Optical is found its way into things like cameras, and they're looking at increasing the data rate capabilities as well as the flexibility of the standard with 13 to apply to more and more devices. So these are the ongoing projects which we expect to see producing standards or standard amendments in the next 2 years. And of course, we're always interested in new ideas, always looking ahead. So, and we have a vehicle for that too. Again, if you show up, if you've got an idea, we have a venue we call Wireless Next Generation, which is an opportunity to bring any kind of ideas that you would want to share with the group, possibly to spawn new work in the future.
Okay. Well, thank you. I want to tell everybody in the audience that our upcoming Tech Talk, the next one is on 25 May 2022 about 802.19.3. which is coexistence of the sub-1 gigahertz frequency bands. And this has to do with, I believe, 802.11a, so 15.4, cooperating to coexist and achieve their goals in common bands. And then on the 22nd of June, we're going to have the coexistence of 802.11 and 5G, which are basically the 5G cell phones. That should be pretty interesting as well. So, and we have a list of additional information. Jen?
Yep, thanks very much, James and Ben, for the great discussion today. We really appreciate your time. As noted earlier, the on-demand link for today's event will be emailed to everybody in about 2 hours. And if you go to the resource list, the green resource button on your screen, you'll find links so you can register for those next Tech Talks. The next one is on the 25th of May. And before you leave, if you could please complete our feedback survey at the bottom of your screen, we would appreciate it. And we thank you all for your time, and have a great day.
Thanks, everyone.